This is Geometry Lesson 4-1, Intro to Similarity. Welcome to your new unit. Sorry that it has to be online. Let's jump right into this. So let's do zoom. There we go. Today's date is Thursday, January 28th, 1/28, 2021. Our objective today is use the definition of similarity to decide if shapes are similar. That's the first part. Second part is solve rational equations, and this is kind of prepping you for what you're going to be facing in your future here. So I think a good way to talk about similarity is to compare it to being congruent. I consider congruent like the very hardcore, maybe older sibling type of statement, and being similar is like the younger sibling, not as powerful, but still means things. So when you're congruent, that means that two shapes are congruent if they can be mapped onto each other with rigid transformations. And rigid again means those three things. It means translations, it means rotations, and it means reflections. Ran that from there, whatever. Those are your three rigid transformations that we use in geometry. With similar shapes, it's basically the same thing. As two shapes are similar, again, keyword, similar versus congruent, if they can be mapped onto each other with, again, rigid transformations. I think I'm missing a word right here. Rigid transformations, all right, transformations, and or dilations. So you can still use translations, rotations, reflections, but you're also allowed to use dilations, but you don't have to use dilations. If you're still using translations, rotations, reflections, and it works without a dilation, yes, you are congruent, but you're also similar as well. I should also note that vertical and horizontal stretches and shrinks are not dilations. So if you ever see a vertical or horizontal stretch or shrink, you can automatically say, nope, that's not similar. And there's some things on the homework tonight where it'll say something along the lines of, well, they're congruent, but they're not similar. No, if they're congruent, this always implies that they're also similar. It's impossible to be similar but not congruent. So let's try an example. This is not like a Khan Academy example. Khan Academy will have a student actually doing this problem, and you have to decide if they made an error or not. We'll just do them. So I have these two triangles, and I have to determine if they're similar. And the only way that I know how to do that with our definition is use transformations. I have now four. I have translation, rotation, reflection, and now dilation. I could use all four of those in my toolbox. If I can get one shape to map onto the other, I win. They are similar. So let's try to do this. Right away I see two right triangles, a big and a small. I'm going to try to rotate. I see that this is the right angle and this is the right angle. So I'm going to go ahead and I think I'm probably just going to translate this directly on top of A. So I'm going to say translate D to A. Technically I mean 1, 2, 3, 4, 5, minus 5, and then down 4. Next I'm going to rotate, just so that both of the the sharp corners or the smallest angles of the triangle are both pointing up. So I'm kind of mapping this bigger triangle onto the smaller triangle. If I'm doing that, that means I'm going to have to rotate around or about point, I can't spell here, point D. And then how many degrees? Well, I want to rotate this direction by 90 degrees. This is counterclockwise, which is positive. So we'll say by, can't spell here, by 90 degrees. Okay, now they're both pointing up. The problem now is I have some shape that looks like this. I kind of ran out of room here, but I now have this triangle. This is where F prime prime is. I've had two transformations. And then E prime prime is 1, 2, is like right about here. It's not the same size, so I'll say that this is our E prime prime. It isn't fitting onto this triangle yet, but we're allowed to use it. Dilation, that is the final transformation. Dilate about point A. So everything is going to shrink towards A. By what factor? We want half, right? Because the total length between this, I guess, is D prime prime and F prime prime, or D and F, because we haven't done any non-rigid transformations. This is still the same length. This length is 4, and we're trying to get to a length of 2, so we need a half 4. Same thing with DE. DE, this length is 1, 2, 3, 4, 5, 6, and we're trying to get to a length of 1, 2, 3. We need to take half of it, so our dilation factor is 1/2. And we've done dilations before. I know we'll have to kind of dust off that knowledge. But there it is. So these are 2 rigid transformations, and then we have a dilation. Those are the rigid. It doesn't really matter. You just need to know, because we were able to map one triangle onto the other, we conclude therefore, and then the congruency, or sorry, it's the similarity statement, not this congruency statement now. We'll practice writing. Therefore, triangle ABC, ABC, and you do have to get the correct order here. A is the right triangle, so I'm going to say D, and then it goes to the sharp corner B, so sharp corner BE, so we'd say D, E, F. They're in the right order. We used to write this symbol for congruent. There's a new symbol out there. It is similar. It's the lazier version of it. There's no equal to sign underneath. It's just the squiggly. I think it's called a tilde. On the keyboard, it's right above the tab in the top left. That means similar to. I'll write that over in the notes. This means similar. All right. Thank you, mail. Go away. So, example number 2. Are these 2 quadrilaterals similar? So, eventually you'll be learning about the angle-angle theorem. Whenever you have a triangle and you know that 2 angles are the same, say we knew this angle and this angle were the same, and this angle and this angle were the same, that is enough to use the fact there's 180 degrees in triangle to say, oh yeah, that angle must also be the same. If all the angles are the same, then the 2 triangles are similar. It is a way to prove that triangles are similar just by their angles. The problem is that these are quadrilaterals. So yes, their angles are all the same. Right angles, then 108, 72, 108, 72. All the angles look the same, so at first glance, if you're really experienced with triangles, you might be like, oh yeah, the angles are all the same, they're congruent, but they're not. Or they're not, they might be similar with that statement, but they're not even congruent. They're not even close. Like, look at this. I have 1, 2, 3, 4, and I have 1, 2, 3. So those don't match, but these, that x dimension doesn't match, but the y dimension does. 1, 2, 3, 1, 2, 3. The only way that you're going to map one shape onto the other is with a horizontal shrink or compression. Like if I were to somehow have some horizontal stretch by a factor of 4/3, then I could get this length to 4, but I'm not allowed to do just horizontal stretches. I have to do a dilation, and a dilation does both the x and the y dimension at the same time. I'm not allowed to just pick one of the dimensions. So the answer here is no. No. And I can just type to make this a little bit faster. Let's do 14 font. No. Impossible to map one quadrilateral to the other unless you use a horizontal stretch or shrink. And I kind of want to make all that font blue just for the sake of having everything kind of looking the same. Nice. All right, well, that's kind of the first homework assignment that you'll see on Khan Academy. The second one that you'll see on Khan Academy is preparing you for solving similar triangles in your future, which is solving rational equations. So I have all of them are example 3. Mr. Sindel, what are you doing? That should be 4, and that should be 5. So silly. I was obviously making these notes too fast tonight. How do you solve these? And I think it's a good idea to pause for at least 10 seconds. Try to remember how to do this. So you unpause, and the answer here is just to cross multiply. So I'm going to cross multiply. It doesn't matter which direction first. I'm going to go that way. If I do that, it's going to be 1 times the quantity of 3x plus 8. And that's going to be equal to, and then cross multiply the other direction. So this is going to be 10 times x minus 2. And you might be noticing I'm writing this with parentheses, and I have to be careful when I cross multiply because I'm really distributing into each other. I mean, with the 1, it's kind of silly to say, okay, the 1 distributes into everything and it's used up and it's still 3x plus 8. So I can still say, yep, that's 3x plus 8. But on the right-hand side of my equation, well, it might be your left, I don't know which side you chose, but on this side of my equation, I do have to distribute, which means I did have to have these parentheses. It does affect the problem. The most common error that I see when students are working on this problem is they'll just write 10 times x minus 2, and they'll be like, order of operations, 10 times x is 10x minus 2, and they'll forget to distribute. So remember on these problems to distribute. In this case, I have 10 times x, which is 10x, and 10 times this minus 2, which is minus 20. So I'll write the little distribute arrows for the notes. Don't forget to distribute. And then from here is just an algebra 1 problem, right? Let's get the x's on one side. I'm going to go ahead and subtract 3x on both sides, minus 3x, minus 3x. And I might as well just, since I know I'm moving all the x's over here, let's move all the constants to the other side. Let's go ahead and say, let's add 20 to both sides. Add 20 to both sides. I'm doing 2 steps at once. I think you guys can follow it though. What's I can give us? Well, 20s are gone, 3x's are gone. What do I have? On this side I have 20 plus 8, 28. On this side I have 10x minus 3x, that's 7x. And then finally let's solve by dividing by 7, and I get x is equal to 4. And I totally chose random numbers when I was making this. I was hoping this would come out to a fraction, because most of the time when I was working on Khan Academy, these came out to fractions. This is magically a nice number, but expect fractions on Khan Academy. If you get a fraction, that's still probably correct. On to example number 4, not problem 3 again. This one looks a little bit tricky, because how, like a fraction equal to a fraction, yeah, I can cross multiply. There's no fraction on the right hand side. Again, I would really appreciate if you guys could pause the video and attempt this problem on your own. Okay, you've unpaused, so make it a fraction. It's 6 over 1, there's your fraction. And then cross multiply, so cross multiply that direction, negative 7 times 1. Okay, well that's easy enough. And then cross multiply the other direction. So if I cross multiply this direction, I'm going to distribute this 6 into the y plus 5. And 6 times y is 6y. 6 times 5 is 30. I'll draw the little distribute marks as well, just to have it for our notes. The left-hand side of the equation is just that negative 7. All right, I'm almost there. Let's go ahead and move all of the constants to the left-hand side by subtracting 30 on both sides, minus 30. So that gives us negative 37 on the left-hand side. The right-hand side, I'm just going to use all green now, is 6y, because that canceled out. Yes, I finally got a fraction. Good. Okay, this is what it typically looks like on Khan Academy. Next up here is to divide both sides by 6. Divide both sides by 6. This is going to be negative 37 over 6, and that is what our y is equal to. You will type in negative 37 over 6. Don't try to make this a mixed number. I know you can think, oh, it's negative 6 and a 6, and then 1 6 is really, I don't even know, what is that, 0.166 repeating or something? I don't know. What is 1 divided by 6? No, it is 0.166 for being. Good job, Mr. Sindel. Pat myself on the back. All right. On to example number 5. Okay, this is the hardest type of problem. I never actually saw one of these on Khan Academy, but this is as hard as a problem that I can throw at you on the test, so just to be wary. Again, it's a cross multiplication problem, so there's just 2 distributes. I have a negative 7 distributing into this 5a minus 6. And that's going to be equal to cross multiply the other direction. Oh, I forgot to say to pause the video. You should have paused the video before I'm going through these solutions. So please make sure you're doing these on your own. That's the best way to learn. If you're just watching me do math, you're doing it wrong. Math is not a spectator sport. It is a you do it sport. I'm going to distribute the 2 into the a plus 1. Okay, let's draw the distribute symbol. 2 times a is 2a. 2 times 1 is 2. Good job. Left-hand side. Distribute this entire negative 7 into 5a. I get negative 35a. I know my a's look like 9s. Maybe I can rewrite that so that people don't get confused. That is supposed to be an a. And then negative 7 times negative 6 is a positive 42. Let's keep that equal sign. All right, I'm going to do 2 steps at the same time. Hopefully we can follow. I like having positive a's, so I'm actually going to add 35a to both sides. add 35a. It doesn't matter which side you choose as long as constants are on one side and the variables are on the other. If all my variables live over here, because that cancels out, that means my constants need to live on the left-hand side. I need to subtract 2 on both sides. That will cancel out my 2's. What is our new equation after doing all this arithmetic? 42 minus 2 is 40, which is a nice clean number. Hopefully this comes out as a fraction. It will. Okay, 35a plus 2a is a 37a, and our final step is just divide by that coefficient, divide by that 37, divide by 37, and a is equal to, yep, those are gone indeed, 40/37, which is a nice ugly fraction. Very typical of Khan Academy. That is all of the notes for today. We have 2 homework assignments, one for the using the definition of similarity, can't speak, and the second homework assignment is solving rational equations. Normally this is when I ask you for the FIS of 5 on our objective. You should mentally be scoring yourself and be ready to ask questions. That's all I've got. I'll see you guys later.